Instrumentation Engineering YouTube channel. In this channel, we are going to understand the electrical and instrumentation related videos in 3 languages: English, Hindi and Kannada. Please subscribe our channel to know more about the channels and the contents. Now let's move into the today's topic, that is the control diagram of PLC system. This is the control diagram of PLC system. I am going to explain now. See, the 110 volt DC AC UPS is available at the source. The source name we can call it as a power phase and neutral. Here the 110 volt DC source is available, and from here now move into the next part. We will add one MCB, and in this MCB the 110 volt DC is extended up to the MCB terminals, and the MCB is turned on, and hence the 110 volt DC available at this point. From this point we will expand the 110 volt AC to the next circuit, that is the bus bar. This is called a 110 volt AC bus bar. Here from 110 volt AC bus bar, from 110 volt AC source through MCB, the 110 volt AC is extended to in this bus bar. This is the phase and this is the neutral. So here 110 volt AC is available. So next moving to the next part. So moving into the next part, we will extend 110 volt AC again to another MCB for isolation purpose. It will explain you. I will explain you in the next upcoming slides. See here, 110 volt AC is drawn from this point to this MCB source, and from this point 0 volt AC is extended from this point to here. And from this point here 110 volt is now 110 volt AC is available, phase is available here and neutral is available here. So now we will extend again the 110 volt AC supply, that is to SMPS. So how SMPS looks here, here we see. So here 110 volt AC from this point we have extended to the given it to the line of the SMPS, and neutral is connected from MCB to neutral point, and the earth point is connected to the earthing, that is grounding made to the panel. So now the use of SMPS is conversion of 110 volt AC into the 24 volt DC, because PLC always uses the 24 volt DC power supply. It will not operate on higher voltage side, hence we need 24 volt DC. Hence we have a 20 amps rating SMPS in this control circuit for a utilization of 24 volt DC power supply. Now incoming 110 volt AC is available at this point and this point. Now 24 volt DC is available but this point and this point. Now let's see how 24 volt DC supply can be utilized for a PLC control drawing. Now we will expand this 24 volt DC supply again to bus bar. So this is the bus bar, this is the 24 volt DC bus bar, this is a positive and this is a negative. This is a 24 volt DC available and 0 volt DC available. So these two are the bus bars which are same as the 110 volt DC, but here the voltage remains as 24 volt DC, but here it is a 110 volt DC. Now next move into the further slide, that is PLC rack. So how we can utilize it for a PLC rack? Yeah, here the PLC rack. Let's see PLC rack. So 24 volt DC power supply is given to the power supply module. In the last session I have explained you regarding the configuration of the PLC. In that PLC, this is the power module, this is the processor, and this is the communication module, this is the Ethernet module, digital input module, digital output module, analog input module, and this is the analog output module. So there are total several modules exist in the PLC rack, and the 24 volt DC power supply we have thrown it to the power supply module. From this power supply module, it consists of a base. So through power supply module, it energizes all the module, that is processor, communication module, Ethernet module, DI, DO, EIO, all the module energized by this power supply module. Hence 24 volt DC is given here. And the extended 24 volt DC we have given it to the IO relay boards, that is input output relay boards, which means input output relay requires a 24 volt DC power supply for utilization of a feed power and utilization of a relay actuating a relay board. Hence in this topic we will explain in the part number 3 of the PLC learning video. Now let's move into the next part, that is just a minute. Now again we have extended 110 volt AC from this bus bar to this MCB, because to extend the 110 volt DC power supply to the IO relay boards. See here 24 volt DC power supply is also extended to the relay boards, and 110 volt DC is also extended to the relay boards. Depending upon the application and functions of the relay boards, we have to utilize 110 volt AC source and 24 volt DC source. In this again utilization of 110 volt DC and 24 volt DC in the IO relay board, we will learn in the part number 3 of my upcoming video. This is the part number 2 of video, and in the upcoming video I will explain you about the relay board concept, how 110 volt DC and 24 control DC boards and relay board operates. With the practical example I will show in the next upcoming video. Kindly subscribe my video and let's move into the further topics in the same video. Let's continue the topic. See, next in the next topic we have a Ethernet switch. So for Ethernet switch we need a power supply. So we need a power supply. We have to draw power supply from one UPS only. Hence we have added a one MCB over here, and we have expanded 110 volt DC from bus bar to MCB, and from MCB to power supply of the Ethernet we have given Ethernet switch. Hence the Ethernet switch has been turned on. And the next in next slide we will explain about the operating station and engineering station, how both are connected using the same supply. See here, again we have added a one more MCB here for isolation purpose, because from isolating we can connect the computers to operating station and engineering station. See here, the 110 volt DC supply is connected to the engineering station, and we have extended from this point 110 volt DC to the operating station. Hence the PLC can be operated through this PC, and in the PLC can be programmed or accessed through any changes can be done through this PC. So both PCs are important. See here, let's understand the functions of MCBs. Why this so much of MCBs I have added in the basic control circuit. Here I have added a 32 amps MCB because it consists of a large power rating MCB, and the next I have divided as a 6 amps MCB to each control circuit, because to isolate, if by isolating this MCB I can turn off power supply only to the power racks and SMPS. By isolating this MCB I can turn off power supply to the I/O relay boards. By isolating this MCB I can turn off power supply to the Ethernet switch, and by isolating this MCB I can turn off operating station and engineering station. So based on the functionality required, so I have added a MCB in the circuit. Please see, if in case of any fault in the circuit, the particular MCB only trip, not main MCB, because if the fault extend, if MCB is fault, then main MCB will trip. Otherwise the particular MCB only trip. If there is a fault inside the Ethernet switch, then this MCB will turn off. If the fault inside any operating station or engineering station, then this MCB will turn off. So to identification the problem, the more number of MCB is added for a easy configuration. If any faults in the I/O relay board, then this MCB will turn off. If any faults in the processor side or any SMPS side, then this MCB will be turned off. Hence the number of MCBs we have utilized in this circuit. So in the next video, I will explain you about the PLC models. Just a minute. Yes, in the next video I will explain you about the PLC models to I/O device connectivity. So how PLC models are connected to I/O device connectivity. So this is a DI model, and this is a DO model, and this is a AI model, this is a AO and analog output model. So how Indian devices are connected to the model from relay boards, I will explain you in next video. If you like this video, kindly like my video and comment to my video if you have any queries, and share it to the students and working professionals who can get help from this video, and also subscribe my video so you will get alert in my next video uploads. Thank you for watching.